In this program, we'll use a for loop to fade up the tones on a speaker and print out the value of our variable to the serial monitor that's built into the Let's Start Coding editor. In the void setup function, use the pin mode function with arguments A5 and output to set up a speaker on A5 and ground on your MakerBoard. Use the serial.begin function with the argument 9600 to set up the communication between your MakerBoard and the serial monitor. Within the void loop, there's a for loop, and if you've done the last project, this is the same for loop that we used there, except that we're going to print out the value of the I variable to the serial monitor. This for loop has four main parts. First, you'll create a variable. Next, you'll create a condition that the for loop checks before it runs. You'll create a change to that variable that happens after the code between the curly braces runs. And the last piece is the code between the curly braces that runs when the condition is true. Here, I've created an integer variable shortened to int, and that means it's going to be only whole numbers, no decimals. The name of that variable is I, which is commonly used as a counter variable in for loops, and I'm setting it equal to 40 as the starting value because the speaker sounds best when it's playing a hertz of 40 or above. The condition here checks is the value of the I variable less than 1000. If it is, the code between the curly braces runs, and then I++ runs, increasing the value of the I variable by 1. The code between the curly braces here starts with a tone function with the arguments A5, which is the port where the tone will play, and I, which is standing in for the hertz value we want to play there. The serial.println function is what's going to print out a value on our serial monitor. The argument for the println function is what do we want to print. This can be text or a number, but here we want to print the value of the I variable. And because we're using the println or println function, each time this value is printed out, it will be added as a new line in the serial monitor. Next, we have a delay of 10 milliseconds or 0.01 seconds, where the code pauses before reaching the end of the for loop, jumping back up and increasing the value of the I variable by 1, then checking again if the condition is true, and if it is true, running the code between the curly braces again. Let's run through how this program is going to run when you have your speaker plugged in. We'll create that I variable. It's an integer value, and it starts at a value of 40. If 40 is less than 1000, which it is, the code between the curly braces will run, playing a tone of 40 hertz on port A5 where your speaker's plugged in. The serial.println function is going to print out a value of 40 on the serial monitor, and after a delay of 10 milliseconds, the for loop will end, and I++ will increase the value of I from 40 to 41. The condition is checked again, asking is 41 less than 1000? It is, so the code between the curly braces runs again, playing a tone of 41 hertz on port A5, and then printing out the value 41 to the serial monitor before delaying for 10 milliseconds, ending the for loop, increasing I by 1, and checking the condition again. This is going to happen over 950 times as I scales from 40 to 1000. After I equals 999 and plays a tone of 999 hertz on the speaker and prints 999 to the serial monitor, there will be a delay of 10 milliseconds, the for loop will end, and I++ will increase I from 999 to 1000. Then the condition will check. Is 1000 less than 1000? It's not, so the code between the curly braces is skipped. In this case, there's no other code inside the void loop to run. So the void loop comes to an end on line 17 with this closing curly brace, and the code is going to jump back up to line 11, and it's going to reset the value of I to 40. It will check the condition, is 40 less than 1000, and because it's true, it's going to play a tone of 40 Hz on port A5. So if we upload this code to MakerBoard, and then press the monitor button and scroll down, we can see the value of I is rising really fast once every 10 milliseconds. And it will get to 999 and then jump back down to 40 and start rising again. You'll hear all of these tones very briefly on the speaker. And you can play with the delay that's inside the for loop to change what that sound effect is.